Alright, so we're going to worry about constructing a confidence interval for proportions, okay? And we're going to look at this talking about presidential election here. Since this is going on, we'll just go ahead and work that into our problem here. So let's say we select a random sample of 50 ballots for the presidential election to review. We want to calculate the proportion that are in favor of former Vice President Biden. We're going to let the p-hat equal the proportion of ballots that are for Biden. In this example, we're just going to use a random number I came up with. We're going to say in our 50 ballot sample here, we're going to say our statistic was at 0.42, so 42% were in favor of Vice President Biden. So with that, we've got our setup here. Now, also, remember, when we've talked about this, this is also our point estimate in that case, right? This is our PE, our point estimate, okay? So our point estimate. So it's going to be the main focal point we're building this around. Okay? Now, the next thing we need to talk about, just make sure we've got everything lined up and know what we're talking about. Let's go ahead and identify a few things here. So first off, what is our population? Okay, so the population is going to be all presidential ballots, right? So population is all presidential ballots. Okay. Now, what's our parameter? So our parameter, in this case, what we're looking at is going to be the true proportion of ballots that are for Biden. Okay, so our parameter is the true proportion of ballots for Biden. Oh my goodness. That's a crazy S. Go ahead and fix that real quick. Ballots for Biden. Okay. And then we're going to look at what our sample is. For our sample on this, exactly what we talked about in the beginning of the problem, 50 ballots, right? We took 50 ballots. That was our sample that we used to look at to construct our point estimate. Or, in this case, our actual statistic, right? So our statistic, in this case, is going to be our p-hat, our point estimate, which is 0.42. Alright, so that all took care of that data information to make sure we know what we're talking about here, population, parameter, sample, and statistic. So now we need to make sure we've got a few things checked off here for conditions, right? So we're going to cover 3 conditions, all right? So with this, our first condition we're going to cover, I'll just right underneath here, we'll say our first condition is going to be a random, right? It's all random. In other words, our sample is random. The second condition we're going to look at, so we're say the 10% condition. Right? Hopefully you guys remember what that is. Remember, 10% of the entire population. So 10% condition. Okay, and our third condition, we're going to do 3 conditions. Our third one is to see if the curve is approximately normal, right? And to find that out, the approximately normal, we use our large counts. So large counts. Which again, that was going to be our n times, in this case, a proportion of p-hat. And we're going to say if that's greater than or equal to 10. And we're going to say our sample size times 1 minus our p-hat. And if that is also greater than or equal to 10. Okay? So the 10% condition allows us to use our formulas for calculating this data, and the large counts describes the shape of the distribution, whether it's approximately normal or not. Okay? So going with this, let's look at this first condition. So, was our sample we did random? Well, we had up here in the problem, we did a random sample, right? We took a random sample of 50 ballots. So, yes. In this case, for condition 1, we had yes. We did a random sample. Okay, so we should make sure that that sample is random. Therefore, there's no bias in that condition. Now, with that, also, let's look at our 10% condition. Our 10% condition, we're saying that we got 50. We're seeing if that's less than 1/10 of all ballots. And I'm pretty sure anybody who's been watching the election knows that yes, 50 is definitely less than that, okay? So we're going to say this is yes.
I want to paint my makeup.
Okay, Maddie. Now also, then we're going to look at our large counts. So large counts, in this case, we're going to take 50 times 0.42, which that's going to equal 21, which then is greater than or equal to 10. So that checks off. Now we're going to take 50 times 0.58, because 1 minus 0.42 is 0.58. And we should get a bigger number, which is 29. This will be greater than or equal to 10 as well. So we checked off. So all three conditions were met, okay? So therefore, when you're writing out this and you have to go through any conditions, check this off to make sure you can go forward and can
Can you get this open?
So again, all these conditions need to be met to move forward with this. It's got to be random, 10% condition, and large counts. We're dealing with proportions, okay? So now, since we know we've got our 10% condition, and we can use a specific formula here, because we need to calculate our standard deviation. So we have our point estimate. We need to count our standard deviation. That's going to go from that point estimate. So for this, get a different color here. So for our standard deviation, we're simply going to use the equation. So for our p hat for our sample proportion is going to equal, again, we've gone over this as well, say your proportion value times 1 minus p over your sample size. Well, that is the base formula setup, right? That we go off of this. Well, we don't know the true proportion of ballots overall. In that case, if we do not understand the true proportion overall, we can simply use our p hat value, okay? So since we do not know the true proportion of the entire population of ballots, we're going to use our sample proportion that we got. So our p hat is 1 minus our p hat all over our sample size. So for this, that means it's going to give us a square root of, we've got 0.42 times 0.58 all over 50. And therefore that should give us 0.0698. 0.0698. Okay. Now that gives us our standard deviation, our p hat. With that, that can also be viewed as we also talked about, as being your standard error, which standard error is abbreviated by S E, a capital SE, and then put your little p hat here, so we know so much your sample proportion. So your standard error. So again, that is your standard error. Okay? So your standard error is going to be the standard deviation. Now the standard error is going to help you calculate a few things. We'll get to that in a second. What we need to talk about here is, with this, we need to calculate a different thing for our formula here, because there's a different little part here to calculate our margin of error. So our margin of error, value for our proportions is going to be a calculation of your critical value times your standard error. So your critical value times your standard error of your proportion. Okay, that's what we use to find our margin of error. So the critical value is based off the confidence level that you put. In other words, if you're 95% confident, if you're 99% confident, if you're 80% confident, whatever confidence level is going to be the value that is going to allow you to calculate your critical value. Okay? And we're going to talk about that here real quick. Okay, so we've talked about this a little bit. We're going to explain a little bit more in detail here. So when we look at trying to find our critical value, we need to think about something here. So we talked about, right, when we have our normal curve, if we have a normal curve and we're going to look at this and say 0, and we're going to go +1 and -1, we said that that was 68% of the data, right? So we said that was 68% of the data to handle between -1 and 1 standard deviation away. And to go from +2 to -2, to do that, we said that between those two, that's 95. That handles 95%. Okay? So let's think about that, right? 95%. So if you're 95% accurate, your critical value technically should be a 2, right? Because you're going 2 standard deviations away from the mean, in which case is 0. However, though, for your more accurate number, it's a little bit different than that. And to find the actual value that handles between, the actual value that is from the mean, that handles 95% of the data, we're going to use, in our calculator here, an inverse norm. Inverse norm feature. Okay, which on your TI Inspire is menu 653. Okay? So the only other trick you have to do here when you're using that is you need to calculate the area when you're finding this, okay? So the area to calculate, to find your inverse norm, you're going to take 1 minus the percentage that you're looking at in decimal form and divide that by 2. So in this case, let's say we're using 95%. So we're going to take 1 minus 0.95 and divide that by 2, right? And so therefore we should get 0.025. Now you technically don't have to do that calculation beforehand on TI Inspire because it's kind of helpful in the fact that it allows you to put that in there. Here you go here, menu 653 for inverse norm. The area there, you can type out the equation. So you can just simply say, I'm going to go 1 minus 0.95, and you're going to divide that by 2, and mean is 0, so is 1, hit enter, okay. And you're going to get a negative value, because looking at the left-hand tail over there, right? In other words, it's telling you from that 2.5% area under the curve, it's giving you the value of negative 1.95. So in other words, what it's telling you here is, it's telling you this area right here is 2.5%, right? So the actual value here is not a negative 2, it's negative 1.96. And just like if we do this up here, taking this value up here, you have a positive 2.5% on that upper tail, which that is a positive 1.96. And when you're using your critical value, you should always use the positive value, okay? I know the calculator gives you a negative 1.96 because it's finding the lower tail, but you always want to use the positive values. So in this case, since we did inverse norm, and we said we had 0.025 for our area, we had 0 for our mean, and 1 for our standard deviation, and we got for that value to be 1.96, and 1.96 is our critical value. Okay. In the world of proportions, that critical value is called your Z star. So your Z star is 1.96 when you're 95% confident. 95% gives you a Z star of 1.96 every time, okay? So with that, you can do that on any type of value. I just use 95 to show you on that, but you could go through and do any other values you wanted to, okay? Now, if you're using the Desmos calculator, again, that link that I'll put down in the description below is going to deal with here, in which case we need to know what that 1 minus a percent divided by 2, which we know that that is, I'm just going to go ahead and say it's 0.025, okay? Oh my goodness, that didn't write out what I wanted to do. Let's go ahead and type it in there. That doesn't work for me. So this one is be 0.25, and then we want to find for the left, just right here. And as you can see, the value gives us negative 1.95999 or 9964. So again, that still gives us our 1.96 for our critical value. All right, so let's find out what our confidence interval is for the president or Vice President Biden's ballots, okay? As far as being out of that sample of 50, let's see what our confidence interval is. So we said that we had 0.42, I believe, is our point estimate. All right. So we had, again, our p hat, our point estimate was 0.42. And we said that our standard error of our p hat, also known as our standard deviation of our p hat, which was 0.0698, okay? And now we need to find out our margin of error. So again, our margin of error is going to be our Z star times our standard error. So if we're 95% confident here, we know our Z star is 1.96. And we're going to say our standard error in the p hat, which was 0.0698. So we should get the value of 0.137. So margin of error. So if we know that our point estimate is 0.42, we know our margin of error is 0.137. Again, to find our interval, for our confidence interval, so our confidence interval is going to be your point estimate plus or minus your margin of error. So therefore, we have 0.42 plus and minus 0.137. And that should give us the values of 0.283 and 0.557. Okay? So therefore, that is our interval. Our confidence interval goes from 0.283 to 0.557. Okay? Now with this, again, if you think about this, our calculations, you can sum up these calculations with what we've done here, right? Oh my goodness. What we did was we took our p hat value plus and minus our Z star value times our standard deviation, which was, in this case, our p hat times 1 square root of p hat times 1 minus p hat over our sample size. And that calculated our confidence interval. Again, this is the base formula of point estimate plus or minus margin of error, but the actual root equation to use is right here. P hat plus or minus Z star times the square root of p hat times 1 minus p hat over our sample size. Okay? And that gave us our interval. So now that we have the interval, in other words, what we're saying is we're 95% confident that the amount of ballots that are in favor of Vice President Joe Biden are from 0.283 to 0.557. Okay? So with that, that is calculating our confidence interval. So I hope you learned a little bit of something on this confidence interval, and I'll see you next time.